Thank you for joining me. I am Mr. Ish. I hope everyone's doing well. We're looking here at a practice question, but this practice question brings up a particular issue that can arise when you're solving these type of questions. A inhomogeneous differential equation, because it's equal to something and that something is not zero. It's not homogeneous. It's inhomogeneous or non-homogeneous, where your function f of x, what your differential equation is equal to, is an exponential function. As you can see, we've already seen a video of this form, but here we're looking at what you do when a particular issue arises and it prevents you from solving it. There's a specific technique you have to take. We have to address that in this video using this example. We have here a second order non-homogeneous differential equation, y double prime minus 6y single prime plus 8y is equal to 8e exponent 4x. You know the solution of this, the general solution, is equal to a complementary function plus your particular integral. We're starting with this, and for that you're looking at the left hand side and you're equaling it to 0. You're treating as a homogeneous. What do I have? Y double prime minus 6y single prime plus 8y is equal to 0. And then we go from here. The first order derivative of this is going to be r e to the rx. The second order derivative will be r square e to the rx. You bring that in right over here. I have r square e to the power of rx minus 6r e to the rx plus 8 e to the rx is equal to 0. We're here finding the complementary function. Isolate the e to the rx, you'll have r square minus 6r plus 8 is equal to 0. When you push this on the other side, it divides by 0 and you can just remove it. I'm looking here at r minus 4 and r minus 2 as the factors. R is equal to 4 comma 2. Therefore, we can easily present this complementary function. The complementary function will be this: y is equal to a e to the power of 4x plus b e to the power of 2x. You can alternate the 4 and the 2. You could have put the 2 here, you could have put the 4 over there, it doesn't matter, but that right there is our complementary function, and it is done. Let's look at the particular integral. The problem will arise with this. For the particular integral, we're focusing on the right hand side. You know we have the form y is equal to e to the power of kx, because there's a positive exponent. Therefore, we can use a e to the power of kx, or we can use c e to the power of kx. And what is the value of k over here? It's exactly the value here. K is equal to 4. Therefore, we're saying y is equal to c e to the power of 4x. That's what we have. You can even say a e to the power of 4x. The first order derivative of this is 4c e to the 4x. The second order derivative is 16c e to the 4x. You know the derivative template for exponential is not hard. You have to plug these items. This, right in here. My second order derivative is a 16c e to the power of 4x minus 6 times the first order. 6 times 4 is a 24. So why don't we just make 24 c e to the power of 4x plus 8 times your zero order derivative, which is your original item, your original function item, 8c e to the power of 4x is equal to 8 e to the power of 4x. Now look what happens over here. I have a 16 plus 8 is a 24, minus 24 I'm getting here 0 is equal to 8 e to the power of 4x, and that's a mistake right there, and we're stuck and we can't proceed. So what happened and why did it happen? This is it. Look right over here at these items I'm unboxing. Right over here, and then when you look right over here, this item right here, this could have been A or it could have been a C, but it mirrors exactly what you have in your complementary function. At any time, the item you're using for your particular integral, it mirrors exactly one of these items in your complementary function. You'll have this problem and things will not equal or not equate. Therefore, you have to change your method. And that method is just a bit of a stretch of imagination, but it works. Keep in mind again what happened. The item we're using, the schematic we're using for a particular integral, it matches exactly something here in the complementary function, and that's a no-go. You can't do that. So you have to change something. How will you address this problem? By nothing else other than bringing in an x. Cx e to the power of 4x. Solving these type of equations is trial and error. The thing is, someone has already done the trial and error for us in the past and shown us that we can put an x over here and it solves everything through. So now this is what I'm using. You can say cx e to the 4x, or you can say a x e to the 4x, but it no longer looks like that. So that's what we're using. But now keep in mind, something has happened as a result of this. We have a product of functions. So when we do the derivative determinations, we have to run through the product rule. The first order derivative is going to be what? It'll be the derivative of this. You can put the c out. You can do the product rule of these two items. You'll have e to the power of 4x plus 4x e to the power of 4x. That's your first order derivative. Open it up. You have a c e to the power of 4x plus 4c x e to the power of 4x. Now you have to do the second order derivative of this. So you have to run the product rule over here again for this part. Derivative here is easy. It'll be a 4c e to the power of 4x plus. Now we'll do the product rule over here. I'll isolate the constants. I have here an e to the power of 4x plus 4x e to the power of 4x. When I open up all of this, what will I have? I'll have a 4c e to the 4x plus 4c e to the 4x, which will be an 8c e to the power of 4x. I'll make this capitalized because that's what I want it to be. I'll have this 4c times this 4x. It'll be a plus 16cx e to the power of 4x. That's my second order right there. Now we have to bring in these items in our original equation. What do I have? My second order derivative is this: 8c e to the power of 4x plus 16cx e to the power of 4x minus 6 times your first order derivative, which is all of this. It'll be a minus 6c e to the power of 4x. Minus 6 times that 4 is a minus 24cx e to the power of 4x plus 8 times your original function, which is right here, cx e to the power of 4x plus 8cx e to the power of 4x is going to equal what we have over here. Now you'll notice we can solve it. Look right here. I have an 8c minus 6c, which is a 2c e to the power of 4x. I have a 16cx minus 24cx plus 8cx. They cancel out entirely, but that's fine. We can still solve this out. Is equal to 8 e to the power of 4x. Cancel out the exponential terms. I have a 2c is equal to 8 and c is equal to 8 divided by 2, which is a 4. So when you look right over here, now I know my particular integral, which is right here. My particular integral y is equal to c, which is 4x e to the power of 4x, and we've determined it. And it should be right. The only thing you need to remember, looking back several minutes, is when something looks like this in terms of your schematic for your particular integral determination, or something which looks like this, then you have to bring in the x, and then you proceed from there using the product rule of derivatives, and that will take you to your solution that you're looking for. Let's post our general solution. Our general solution is this: y is equal to, bring in your complementary function a e to the power of 4x plus b e exponent 2x plus this, your particular integral, 4x e to the power of 4x, complementary function, particular integral, but all of this is our general solution, and it should be right, and we are done. Before we close out, keep in mind in these items right over here, because your solutions were r was equal to 4 and 2 is no different than you saying 2 comma 4, so they can interchange as needed. You can also say you could have a e exponent 2x plus b e exponent 4x plus 4x e to the power of 4x. These items over here can change based on how you use them in terms of order, and that is negligible in terms of your solution. But we are done. Thank you for watching.